Okay, so looking at more trig identities, these are a little bit more difficult, and it's stuff that you may or may not have seen in grade 11. It's definitely a grade 12 topic, but some teachers do show them in grade 11. So we're looking at compound angle formulas. So it's what I typically do is look at the sine ones individually and then look at the cosine ones individually. If you're looking at the sine ones, the plus, we have sine x cos y plus cos x sine y. And then sine x cos y minus cos x sine y. So all that switches is the x and the y's, but the plus and the minus stay the same. Now if we look at the cos version, it's cos x cos y minus sine x sine y, and that goes with the plus, and then cos x cos y plus sine x sine y, and that goes with the minus. That's why I like to look at it in that order. I don't really care how you look at it, but you need to figure out some way to kind of memorize these when you're doing them. Looking at a question, you can always look at, like, I can sub values in like pi over 3 and pi over 6 for x and y, and we can do like a left side right side check to show that this is true. Okay, we can use a lot of different other angles, but it's nice to use pi by 3 and pi by 6, because when I go down the left side, pi by 3 minus pi by 6 is actually just equal to pi by 6, because 2 by pi by 6 minus pi by 6 is pi by 6, and that's root 3 over 2. Now on the right side, there's a little bit more work because you just have a little bit more substituting, but the angles actually work out a little nicer. So we get root 3 over 2 times a half plus a half times root 3 over 2, which is root 3 over 4 plus root 3 over 4, which gives us 2 root 3, because there's 2 root 3's over 4, and then that of course reduces down to root 3 over 2, which was the left side, and we've now proved that the left side equals right side. It doesn't say proof, so we don't need to put a therefore or left side equals right side or anything like that. It says show that they're equal, and we've shown that the left side is equal to the right side here. I'm going to let you try this one on your own. The one thing I'm going to show you is you do need to use related acute angles here, and you want to be careful with your plus and minus, because that one right there is not in the first quadrant, and it's going to work out a little differently. And check out, there's a unique angle with this one. Finally, when using the appropriate compound formula to find the exact thing for sine. First, we know we're going to be using sine, so it's either going to be sine x plus y or x minus y. Now what we need to think about is these angles, pi by 3, pi by 4, pi by 6, and kind of pi by 2 or 3 pi by 2. You can also think of, I guess, 0, pi, and 2 pi. But really it's these three angles, and we want to be able to make that pi by 12. Now I can't add any of these three angles, pi by, or 4 pi by 12, or 3 pi by 12, or 2 pi by 12 together to make pi by 12. The unique thing is that I can go from my original special angle to something with the common denominator of what I was looking for, and I could do like 4 minus 3 or 3 minus 2, and they both will actually yield the same answer of pi by 12. So first I need to do a minus, because again I can't add anything together to get to that answer. I'm going to choose the pi by 4 and pi by 6, so 3 minus 2. So when we're looking at that, we've got pi by 4 minus pi by 6, and you notice I didn't actually use these. All I did was change the denominator here to figure out which angle I was going to use. Now 3 minus 2 is 1 pi by 12, so I'm using 4, or pi by 4 minus pi by 6, and that's what I'm subbing in down here, rather than the version with the common denominator of 12. And now I'm actually just going to go through and get all of my special angles, get my answer, and I'm not going to rationalize the denominator because I really don't care that much. But if you did, you would just multiply root 2 onto the top, you'd get root 2 minus, or sorry, root 6 minus root 2 all over 4. But I don't need to see that. This is fine for me for this course.